Welcome back to the LAC3 training series. This video will focus on mapping a suspended full-range or subwoofer array. After the venue has been drawn, click the Mapping tab at the top of the screen. Mapping mode will replace the venue plane controls on the left-hand side of the screen with loudspeaker system parameters, settings, and cabinet controls. Additionally, the workspace screen will now show the default loudspeaker system. Begin by selecting the product type from the Array Parameters dropdown, and then the model speaker being used under System Type. The number of cabinets in an array can be increased or decreased by 1 using the plus and minus buttons, or manually entered with a numeric keypad. For now, the frame angle is left alone. Array top and bottom positions are given as X and Z coordinates relative to the same origin referenced in the venue design process. These are dynamic data fields and will update as the array changes in size or as any one dimension is changed. For example, if only the maximum trim height to the top of the array is known, simply enter that number into the Z top field, and the Z bottom will update based on the length of the array. Under the Cabinets tab, every speaker in the array is listed from top to bottom. For system types that are compatible with mixed arrays, the speaker type can be changed to a subwoofer by clicking the drop-down next to that speaker. The array image in the venue workspace will change to reflect the choice. Each cabinet has a ray trace extending off of it and intersecting the listening plane. This line represents the center impact point of each individual array element. Clicking the Calculate Angles button in the Cabinets dropdown will automatically splay the array within the confines of the speaker's available splay angles and create equally spaced impact points along all of the listening planes defined in the venue geometry. This auto-splay functionality also sets the frame angle above. The array angles can be manually refined by clicking and dragging on any ray trace within the workspace, or adjusting the enclosure angle here under the Cabinets dropdown. With the system roughed in, the acoustic response can be predicted using various tools found at the bottom of the screen. With the Prediction tab selected, various acoustic mapping formats can be overlaid on the screen by clicking the dropdown and selecting the desired type. With SPL mapping selected, the workspace overlays an SPL map on top of the venue. The mapping is based on a specific frequency, which can be selected one at a time in the window below. Frequencies can also be adjusted using the sliders. The color scale is shown on the right side of the screen, and the resolution of the mapping can be adjusted below it. Another useful mapping tool is the SPL over distance graph, which can be enabled by selecting it from the Mapping Type dropdown. Once selected, a new graph is overlaid in the workspace below the venue mapping. This SPL over distance graph can show up to 2 specified frequencies at once, each one having its own line type, reflected below each venue plane. These frequencies can be toggled on or off and adjusted in the window below. The SPL over distance graph can also be changed to reflect the response of a range of frequencies by selecting the frequency range under the signal type dropdown. Then, the beginning and ending frequency of the range can be defined using the sliders under the graph. To see the predicted frequency response of the array at various virtual measurement locations, select the Measurement tab. The lower part of the screen will change to show a blank frequency response graph and 8 microphone toggle controls. In the venue graph above, right-click at any one point on a listening plane to add a frequency probe. Each probe is given a number and a color that corresponds with a measurement on the frequency response graph and a toggle control to enable or disable probe. Probes can be moved around the listening plane by clicking and dragging, or deleted by right-clicking at its base. With multiple probes enabled, an average response can be calculated and overlaid onto the frequency response graph by toggling the average slider. Probes that are turned off will not influence the average response. Armed with acoustical prediction data, the array can then be further refined using the controls at the left of the screen. Under the cabinet's dropdown are circuit-level gain and DSP controls. For powered systems, each speaker has its own gain and DSP parameters. For passive systems, the resolution of this control is determined by the amplifier circuiting. For passive systems, the default circuiting resolution can be changed under the settings dropdown. Cabinet circuiting is then indicated using a color band at the left-hand side of the cabinet list. Each circuit will only have one gain or DSP control. Circuiting can be adjusted by selecting a cabinet in the group, then clicking the Remove Group button. New circuits can then be created by selecting the top cabinet of the new group, holding the Shift key, selecting the bottom cabinet of the group, and then hitting the Add Group button. Circuit gain can be adjusted by using the plus and minus controls within each group. The effect of this gain change can be seen live in the measurement window below. Clicking the DSP icon next to a cabinet or circuit will open the line array control panel. Here, system calibration filters can be adjusted. The filters that are available within this window are system dependent. More information on each filter and their use cases can be found in that respective product's manual. Filters are listed in two categories. Array filters globally affect every circuit in an array equally, and circuit filters only affect that single cabinet or amplifier circuit, depending on the system type. For some systems, certain filter types are selectable and can be adjusted by clicking the drop-down arrow. Filters can be enabled with the toggle switch, and parameters can be adjusted by clicking the plus or minus icons next to that parameter, or entered directly using a keypad, or by dragging the slider in the graph above. The predicted frequency response of the array in the graph will adjust to reflect any array calibration filters that have been applied. When adjusting circuit-based filters, the affected cabinets will be listed here, and the circuit being adjusted can be changed using the arrow buttons here. Circuits always start with 1 at the top of an array and increase downwards. Circuits that have active DSP filters will show an orange DSP icon next to them. All filters can be toggled off and back on using the master bypass switch below. Any filter can be deleted by selecting the trash icon at the right of it. And all filters can be removed simultaneously by selecting Master Reset at the bottom of the screen. The X will close the line array control panel. Speaker presets can also be changed by clicking the drop-down next to Speaker Settings and selecting one of the available preset options. The suspended subwoofer file type works similar to the suspended array mode with just a few differences. Begin by creating a suspended subwoofer array. In this mode, the SPL calculation method is a selectable low-frequency average or single frequency. The coverage options allows a suspended subwoofer array to be digitally steered at a specified angle by applying calculated delay times to each amplifier circuit. To steer a subwoofer array, select the desired coverage angle, then choose a coverage direction, and click the Apply Delay button. The calculated delay times will be applied to each circuit and displayed in the left side bar. Clicking Calculate will display the result of the coverage steering. Suspended cardioid subwoofer arrays can also be modeled here by selecting rear-facing speaker models under the cabinet's dropdown. The effect of the cardioid array can be visualized by clicking Calculate. For more information on proper cardioid subwoofer deployment, please see the respective user manual of each product. In the next video, we will review and adjust array mechanical properties and suspension options in the Configuration tab.